Greetings, detectives. Mrs. McKay here, and we are going to work on Case 5, Excellent Exponents, Learning Target Clue 5. So 5. Let's get started by writing our learning target clue. I can simplify and write expressions with exponents and radicals. I can simplify and write expressions with exponents and radicals. So that means if I have an expression that has an exponent or has a number of exponents or has radicals, then I can simplify it. I might not be able to solve it, but I can certainly simplify it. So, and I'll show you what I mean as we go through this lesson. Now, let's go ahead and get started and just do a quick review of some of this terminology. Exponents. So an exponent is something that is power of a base. So here I have x to the third power. X is considered the base, and 3 is considered the exponent. And what that means is x to the third means x times x times x. So I multiply x times itself 3 times. Okay, so there are 3 x's there, so that means x to the third. All right? Now, radicals and roots are they're considered the inverse of powers and exponents. So if I have this symbol, it's called a radical sign. This is called the radical. Then, and I have a number inside here like 4. Then that means the square root of 4, which means what number times itself equals 4? Well, the number times itself would be 2, right? So if I said, what is the square root of x squared? Well, it would be x, wouldn't it? Okay, so the taking the square root of something is the opposite of squaring something. All right, so a root is the answer. The root is considered the answer to that problem. Now, but there are other radicals that we can do. This is just square roots, but we can actually do cubed roots. And now we have to put a little number up here in this little indentation, in the little v. That means what number times itself 3 times makes 27? Well, that would be 3, because 3 cubed equals 27. 3 times 3 times 3 equals 3 cubed, which is 27. And so anytime you see a little number inside the radical like that, just kind of listed in that little indentation there, then that means that we have to figure out what number times itself, that number of times, will give us what's inside the radical. All right? Now, let's get started. So, let's do a little bit of review of working with exponents. My hope is that you did this last year, or if you didn't, that you actually looked at the fact file, which had some videos on reviewing working with exponents. And there's three main rules or kind of properties that we want to remember and learn. The first one is called product of powers, and that's when you have two terms, let's say x to the second times x to the fifth. And we want to simplify this. Well, x to the second just means x times x times x times x times x times x times x. So I have 2 x's and 1, 2, 3, 4, 5 x's, and all of them are being multiplied together. And so I end up with x to the 7th. Now this is something that some of you may notice right away or remember. Oh yes, this is this is when I add my exponents. So, and that's true. If you have x to the a times x to the b, that's equal to x to the a plus b. But the most important thing to remember is that it has to be the same bases. The bases have to be the same. So multiplying, we see that we can do that when we multiply. And if you don't remember this, this is what I say. Always write it out. You don't have to remember, do I add or do I subtract? What do I do? Just write it out and you can see it very clearly. X squared times x to the 5th is going to be x to the 7th, and just count your x's. All right? Now, quotient of powers is when we divide two terms with the same base. So let's think about this one. What if we have x x to the 9th divided by x to the 3rd. All right, x to the 9th divided by x to the 3rd. Well, what does that really mean? It really means x times x times x times x times x times x times x, 1, 2, 3, 4, 5, 6, 7, times x divided by x times x times x. Well, we could simply do some canceling. X divided by x makes a 1, right? And x divided by x here makes a 1, and x divided by x here makes a 1. And so then all that I have left down here is just 1. And I have 1 times 1 times 1, which is just 1, times x times x times x times x times x times x, which is 6 x's. So that becomes x to the 6th, or x to the 6th over 1, which just is x to the 6th. All right? So when we are dividing our powers, then, and if they have the same base, that's always the key, then we could actually just take our top number and subtract our exponent in the numerator and subtract the exponent in the denominator. So this really becomes, if I have x to the a over x to the b, it's really equal to x to the a minus b. See that? Okay. Now, power of powers. Power of powers is when I have something like x to the 3rd to the 5th power. All right? X to the 3rd to the 5th power. Well, what does that mean? That means x to the 3rd times 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 x to the 3rd. Well, what's x to the 3rd? X to the 3rd is just x times x times x, and then I have x times x. I'm not going to be able to get these all in here. You get the idea, right? I've got 3 x's here, 3 here, 3 here, 3 here, 3 here. So 3 times 5 is x to the 15th. Okay? And so if I wanted to really think about what this meant, then I could say that x to the a, which is taken to the b power, is really equal to x to the a times b. Now, you can remember those little tricks and those little shortcuts, or you can just write it out. And you can always be sure that if you just write it out, you're going to get it correct. All right? Let's keep going. let's talk about zero and negative exponents, shall we? Now, I've already told you that any number having definite issues here. Any number to the 0 power is equal to not x. It's equal to what? It's equal to 1. Any number to the 0 power is equal to 1. Okay? And I've told you a little bit about negative exponents. X to the negative 1 really means 1 over x to the 1 power, or 1 over x. So then x to the negative 2 is equal to 1 over x to the second, or x squared. And I have a little rule that I use which says cross the line, change the sign. So when you have negative exponents, you can be certain that it's going to turn into a fraction. So if I have x to the negative third divided by x to the fourth, okay, this really means if I cross the line, I move my x to the negative third below the line, it becomes 1 over x to the third times x to the fourth, which is equal to 1 over x to the seventh. Okay? And we'll try a few more of those so that you get comfortable with that. The last thing that we're going to work on are, not the last thing, but the next thing that we're going to work on are finding the nth root. So that means if I have a number like 81, and I want to find the fourth root, then that means that I have to think about what number times itself 4 times. Okay, so some number times itself 4 times is going to equal 81. Well, that number happens to be 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So 81 to the fourth root is 3. Now you can actually use a calculator to figure this out. If you use a scientific calculator, you'll be able to see that all you have to do is fill in the numbers, okay, and you can figure it out, because you're going to start looking at really big numbers. But you can also just start trying numbers, because if you know if something is to the third or the fourth or the fifth root, you know you're going to be multiplying it a number of times and your numbers get very large. So don't be afraid of them, okay? Try it out. Use your calculator. And the last thing that we're going to do is understanding exponents as fractions. And this is going to take a little bit more time, so I'm going to have you come back and watch the next video. It'll be short, but it will be longer than 2 minutes, which is all I have left.